Hi everyone, I'm Arsh and welcome to this video which is supposed to be a guide from how you take an application which you are able to now run on Docker Compose and containers to Kubernetes. Like, I have created a lot of content on Kubernetes before. We have written blogs on the Todo blog about getting started with Kubernetes, but my goal for this video is to be hands-on exercise workshop kind of thing where we actually see how to use all the concepts we had learned theoretically in those blogs and use them to see how you can migrate an application, a containerized application, and get it running on Kubernetes. Now, I do not claim to be an expert on Kubernetes, so this video is not going to be just me, writing stuff from my brain. We will use Google, we'll use ChatGPT and whatnot. So it really is meant to be like a hands-on guide. Like, I will do things like I would normally, like we would, if some things go wrong, we would fix them live on this video. And the only parts I'm going to edit out are like if some process takes a lot of time or something fails. So it's more like a stream, and I want to try out this format and see how it works. So enough about that, and let's get started. The application I'm going to be working on is our to-do. I don't know, I still don't know how to pronounce it, but our to-do list application, which you might have seen in a lot of the other videos if you follow our YouTube channel. You can clone this application and make sure to switch to the Docker Compose Octeto branch if you want to follow through. So I have this clone, and what I have already done is spun up a Civo cluster. You can use any Kubernetes cluster. I just use Civo because it spins up fast and you can delete it after the video. So that wouldn't be a problem, and let's get started. A bit about our application. We have 3 microservices. We have a React client, a Node.js Express backend, and a Postgres database. So let's first create a folder called manifests, which is where we'll keep all our manifests. The first thing I want to do is have my database deployed. So let's create a file called database deployment.yaml. And to get sample manifests, what I've been doing these days instead of going to the docs has been leveraging ChatGPT because it seems to be more convenient. So let's do exactly that. So if you see, I have not just asked for a Postgres database deployment YAML, but I've also asked for a config map. And now, why have I done that? If you spend some time looking at the application, we have a init.sql which we run, and what this does is we don't just need the database running, right? We need to see if there is, we don't need the Postgres database. We need to see if there's a database called to-do list in it, and if it's not there, we need to create that database. And not just that, but we also need to create a table inside the database. So we need to do all of this initialization, which is there in this init.sql script. And if you go to the Docker Hub image of Postgres, you'll see that they recommend injecting a file. Let's see, there are a lot of init descriptions here, but if we go down a bit, you'll see that if you would like to do additional initializations in the base image you get, they are asking you to put any .sql scripts under this folder docker entry point.initdb. And this is exactly what we are going to do with the help of a config map. So let's see the config map we have and copy paste this, and this basically you see that has a key with the name of the file, and the contents of the file would be whatever script we want to put there. So let's go back here and create a new file called db config map, and I'll paste this. Let's just call it Postgres scripts. That looks fine, and can call it init.sql. And what I'll do is I'll just copy paste this initialization script I had and add it here. Oops. Tab, and this is it. So And you'll see that we were doing this with Docker Compose as well. If you study the Docker Compose for this application, you'll see that, we are placing this file in init.sql, we are copying this via volume. So that's what we basically do here. And then when we go to our deployment, let's see what ChatGPT has given us. Looks good so far. And I'll copy paste this into my code editor and we'll edit it along the way. So let's get rid of this because it's redundant. For the name, I would like to call it database. So I'll change the labels and the name of this deployment to database. The container name PostgreSQL image, latest Postgres image. And now these environment variables, we want to use the one which we have, which we are referencing in our server. So the username and the password is Postgres. So let me add this, and I think the first key is actually the database name, so which is to-do list. And whatever database name you specify here, if you do, then that database would already be created inside this container. So we technically don't need to do this initialization in our script for the database, but I like to still just have it there. You can remove this because we know that if we specify this name here, it will get created. Then container ports, that works fine. Volume mounts, and this is where the script happens. So what will happen is Kubernetes will read that config map Postgres scripts, which is this one, and then it will create a file at the mount path, which would be the name of the key we have specified here in init.sql, and inside that file we will have these contents. And like we read in the Postgres documentation, if you place that file, that script will automatically get run by the pod. So this looks good so far. Let's test things out by running this. So I'll just apply the manifest folder for now. And what I also want to do in this tutorial is I've been trying out K9s, which is I don't know how to describe it. It's like a cool looking Kubernetes UI. So I'm going to run that and we're going to leverage that a bit, and just so things are more fun. Let's wait for it to start. Our manifests are applied. Now I'll just see if K9s is up and running, which it is. So let's see our pods, and if we see our pods, it's showing us all pods, and if I press 1 on my keyboard, it should show me only the pods in the default namespace, and I see the database pod running. So I'll press enter, and if I press S, it will give me a shell inside this pod, and this is the same as exec, running kubectl exec and going inside the pod, but it's just so much more convenient and I like the UI. But let's see what files we have here. We have a Docker entry point folder. Okay, that's nice. Let's check this out. We have an init.sql. We can cat the contents of that init.sql. And we have our script here, but I would also like to verify if the table has been created or not. And for that, I will log into my database as the Postgres user. And then I would like to see all the databases I have. And let me just clear this so you can see this. Nope. Okay, I'll just move the video here. We see we have a to-do list database created for us. Let's just connect to this database and see if we have our to-dos table inside it, which was done by the second part of the script. So if I do -dt here, I see that my to-do table is there. So things should work as expected, but if they won't, we'll debug it and see what's up. But right now I have a good feeling about this. You -q to quit and then exit this. Okay, so we're done with 1/3 of our application. We have our database up and running. Let us now move towards deploying the server, and for that I'll just create a server deployment. Oops. Once we have the file created, let's again go back to ChatGPT and ask it for a deployment YAML. Node.js Express server for a PERN to do app. PERN basically is like the application stack, which is like Postgres, Express, React, and Node.js, which are like the technologies we have used to make this application. And it has given me a deployment YAML which seems to have like some stuff we don't need, but let's just copy paste this and edit it. Now I'll just call this server, match labels, I'll change this to server as well. Containers, sure. This is where we have to add the image, and I've already built this image, so that's the name. Let me just copy this. I don't know if you can copy this part. Okay, you can, that's cool. So I'll call this server, and you need to build your application images. You can run docker build after cloning this repository and push them, or you can just use these images. These are on my public repository. For the container port, let's see the docker compose file, and we see that the backend is actually on port 5050, so I'm going to change this. We do not need these because we are not using a database environment variable to connect to our database. That logic is being handled by the application code. So I think that's about it, but we don't just need this YAML, we also need to expose the server pods, so we need a service for that, and let's just ask us for a service as well. Give me a service. Looks good, simple, and I'll create the file for this, server service.yaml. Hit save, and that's a very big name. I'll just call this server. App selector needs to match what we had here so that it selects the right pods. So app server looks good. Port again 5050, and you should just like keep the port and target port same unless you have a very specific reason to not do that. So that's what we'll do, and I think these are the only two things we need, and we are good to go. So again, let's apply our manifests and test if things are working. Okay, it says the deployment and the service have been created. Let's go back to K9s and type services and see what we get. So I see a service running, and one thing we forgot to do, now that I just remember, is create a service for the database, because if we don't have a service for the database, then the server pods will not be able to talk to the database pods. So here, and let's just copy this and I'll paste it here. Remember, the name of the service should be whatever you are like referencing in your application code, and here the host is database, which should be the name of our service. So that's what we'll do here. And if I remember correctly, the label is also database, so we need to add the right labels. The port I think is 5432, so just gonna copy paste that, and let's apply this. So we see that server service, oops, sorry, I changed the ports on the wrong file. We need to change it on this file, 5432. Database, okay, let's reapply it. So it will say database service configured, server service configured, okay, looks good. If we go here, I see that I have a database service and a server service now. What I want to do is like port forward and check this service is working or not. So I know that the application, if you visit the endpoint for the server service /to-dos, we should see like an empty array of to-dos. So K9 is telling me that you can do Shift F to port forward. So let's do that. It's saying forward to localhost port 50. Okay. So port forwarding is now being done. Let's go back to localhost. What was it? 5050, I think. /to-dos. And we see an empty array. So we know that it is able to talk to the database service. Otherwise, it would have shown us an error instead of an array. So I think we are good so far, and 2 components have been tackled. But I'm just going to shut the port forward, and for that what you can do is like search for pf here, and you'll see that the port forward is up and running, and you can simply just delete this and that will stop the port forwarding. But let's just switch our views to pods, and now we need to tackle the third microservice we have, which is like the React client. So let's create the files for that, and I'll create a client.deployment YAML and a client service YAML as well. And I have too many of these open. Let me just close some of them. What we can do is we can just simply copy paste stuff from our server deployment, because things won't be too different. So we'll change all the mentions of server with client, and maybe change the pod name to front end, and the container port, again we can see that the front end is on the port 3000. So that's what we enter here, and we are good to go. Similarly for the service, we'll copy the server service, paste it on the client end, and change this to client as well. Port again is 3000, and that should make things work. Let's apply these manifests and see that we don't get any errors with our pods or something. But right now what's missing is, wait, before we get to that, let's just verify if this is working. It's in container creating state. Fingers crossed, even though we have done nothing too different here, so I'm not super worried, but it's Kubernetes, you never know. Let's go to deployments, and the client deployment is up and running. Okay, yeah, everything's working as expected. But right now there's a very big problem with our application. Like right now our application cannot talk, like the front end cannot talk to the back end, and that is because if you look at the application code, like if you see some of the requests the front end makes, right, like this input component, you'll see that the URL it's sending the request to is /todos. Now this assumes that both the front end and the back end are being served on the same URL, right, which is not true in this case, because like we have them running on different ports, and they are definitely not behind the same URL or the same host name. And the way to solve that in Kubernetes is with the help of a ingress resource. So that's what we are going to create next. We are going to create an ingress.yaml, and we'll ask ChatGPT for a sample ingress. Let's see what it gives us. Yep, this is exactly what we needed. So I'll explain you when we edit this and go through it line by line. So this is just ingress, and we can call this to-do app ingress. That works. Hostname, I'll tell you what we'll add here. So let's leave this empty for now. And this is where we specify that like just / is supposed to, like when you just go to our host name, we want it to go to the front end. So the service name should be like the front end services name, which is client, and the port for that is 3000. But similarly for the back end, we know that the requests are getting made to to-dos, right? Like we saw here in the edit component. So the backend is actually to-dos. So this is what we add here. And the service name for that is like server, and it's running on port 5015. So now both the front end and the back end are being served at the same host name, but we have not added that host name yet. Now this host name needs to be the URL you want to publicly expose your application at. And all of these services which we have seen, like the front end, the back end, they were of the type cluster IP. Now cluster IP services do not get automatically exposed to the internet. You have to use a load balancer type service for that. But the way to do that is like actually have like this ingress resource, right? When we create this on our cluster, it won't work by default. And if you have like a vanilla GCP cluster, it won't work for you. What you need to do is ingresses like only work if you have a ingress class installed. So if I get ingress classes here, you'll see that I have a traffic ingress class installed, and this is something that Todo does automatically for you when you launch your cluster. So it installs applications for you. Now it might or might not be true for you if you're using a different cloud provider. So if you're using, for example, GCP, then you will have to install an ingress class, and the recommended class is like Nginx ingress. So I would recommend you go install that. We won't be covering it in this video, but once you have that ingress class installed, the steps remain the same. So in this case, let's just work with traffic, and what we need from this ingress is like a IP, an external IP for the load balancer. We need to create a load balancer, and we need that load balancer's external IP, which is where we'll create a DNS entry and point it to that IP so our application actually gets served. So if we see here, for the external access to your services, they tell us about an ingress, but I don't see anything about a load balancer service. So let's check their official documentation and see what we have. Getting started, yeah, quick start guide, Kubernetes. So we don't need this cluster role and everything because Todo took care of all of this for us. So deployment, like we already have traffic deployed, right? Like that's what Todo does when it installs applications for you. So if I go to, actually I'm in deployment, so if I just switch my namespaces to all namespaces, you'll see that, wait, let's just go to pods instead of namespaces. So you'll see that I have these traffic pods up and running because they were installed by Todo when I created the cluster. So I don't need this deployment, but what I do need is this load balancer service, which is what exposes, the ingress to like the public, to be publicly accessible. So let's just copy this and create a new file called traffic. I'm pretty sure I've spelled this wrong, but okay, never mind. Let's just create a traffic service.yaml, hit save, and I'm fine with these names, but I want it to be in the names, not the default namespace, but the kube system namespace. So let's just copy this, and load balancer, all of this is fine. The selector actually needs to select the traffic pod, so let's just make sure that the labels are correct. I'll just press enter, go to this pod. It's saying something failed, but okay, I don't see anything here. Let's go back. Maybe it's this one. Okay, I can see a running container. How do I see the detail? Okay, describe, press D for describe. Okay, let's describe this, and we can start to see the labels for this. And under labels, I see that the label to identify, which seems most unique to this one, is app Kubernetes name. So I'm just going to copy this and replace the selector here. Now this is something you would know if you have like gone through the Kubernetes basics blog we have. Basically how services work is you need to specify the labels of the pods you want the service to expose, and in our case we want to expose the ingress classes pods. So that is why we create a service of load balancer type, and we select those pods under the selector field. Once this is done, like let's apply this particular manifest. Right now I'm not applying the ingress we have created yet because we need to still add the hostname field there, but let's apply this service and see what we get. Go back to K9s, see services. Okay, we see a traffic service and we already see an external IP for this. So this is the IP which exposes like the ingress. So if we go to this, okay, we see a 404 page not found, which is like the page when you, since we are not serving anything, we are getting it. So we know that like we have successfully exposed our ingress class to like a publicly accessible IP. What we now need to do is create a DNS which points to this IP, and then that DNS we'll mention in our ingress. So I'm using Google Cloud DNS for this. You can use anything you prefer. I'll create a record set and I'll name this the name of this application, and in the IP address I'll add the same IP for the load balancer for the ingress and ingress class, and just hit create. So now that's created, what we can also do is just verify by going to the actual IP. We see the same 404 page not found, so we know that the DNS, like the URL, is now pointing to that IP. And the final piece missing is just mentioning the URL in the ingress resource as a host. So we can just do that and now create our ingress, and hopefully everything should work as expected. I'll just apply all the manifests now, and all of them should be unchanged except the ingress is now created. And if things are working perfectly, we should be able to see our app on this URL like we can. Wow, nothing failed us. That's surprising for a tutorial. But let's test if things are working. Like, hello, we are able to add the to-do. We know that it got added. That's cool. Like, if the front end was not being able to talk to the backend, or the backend couldn't talk to the database, this would not work. But let's see if edit is working. Edit it, and that's working as well, and we can delete it as well. Cool. We successfully took a Docker Compose application and deployed it on Kubernetes. Now, this isn't like a best practices video. Like, this is just to get you started and just to drill down these concepts we have learned theoretically about in our blogs and give you a practical approach to try them out. When you're doing in Kubernetes, they would make a lot of adjustments to this, but it's a process, and we'll make more videos on how to, like what the best practices are. Like, you would have labels for your applications, you would have liveness or readiness probes and all of that. But I didn't want to make this video any longer than it already has become. So I hope you found this useful. I hope this gives you a chance to, get hands-on experience with Kubernetes and provide you a starting point if you are migrating your applications to Kubernetes, or if you're just looking to try out Kubernetes. If you found this video useful and want to learn more about Kubernetes, go to our website octeto.com/blog, and you'll find a lot of useful content on Kubernetes. If you have any questions, please feel free to reach out to us on our community website, which is community.octeto.com. And as always, happy hacking.